Well, uh, one considerable misconception in BDD is that people consider it to be a software development, software testing methodology using specific testing tools like, say, Cucumber. It's not really the case. BDD is similar to test-driven design, and they both are software development methodologies. In TDD, you write unit tests before producing any actual code, and in the beginning, your test should fail. Then you write code, and your tests start to pass. The main benefit of unit tests is that you can execute them extremely fast. I mean, in comparison with other types of testing. That's why they are included in continuous integration and continuous delivery systems. And the reason is that you don't need the whole system to execute your testing library. You can run tests against small blocks of code. But it's also a drawback. To test system properly, you need to run your tests end to end to test the whole system, and not by parts of it. Well, in BDD, unit tests specify not particular functions, but unit's desired behavior. And desired behavior is written in form of user stories. It's a specification written in natural human language, and it could be understood by human. Well, there is also a term, specification by example. It first introduced by Martin Fowler. You may know him. He's also one of the authors of Agile Manifesto. Specification by example. It's a software development method based on a collaborative approach to defining, say, requirements and business-oriented tests. Well, in specification by example, captures and illustrates requirements in using realistic examples. The thing is that human beings learn from examples, and if you use them instead of abstract statements, you will have fewer feedback loops, faster turnaround, less rework, and better alignment of roles within your project. To illustrate this concept, let's look at the slide, how to tie a tie. Yeah, you can try to follow this 11 points of specification. It requires a vivid imagination to convert them into real actions. Well, on the other hand, you can use examples. And it's obvious that such a description would be easier to understand. Well, that's why specification by example could be a good approach. Well, a business analyst, a software developer, and a QA engineer. These three people should be like three amigos. Yeah, you see heads. And they should, say, travel and work on user stories together. And here's also a sample of a user story. Let's go throughout this. At first, it should start with a very clear and explicit title. Then goes a description, which answers to three questions. Who is the user of this story? What would he or she like to achieve? And why it's important to this user. And then we need to define an acceptance criteria. It's like a dragon has three heads, and no spoilers to Game of Thrones. Well, given a set of preconditions, when an event occurs, and then an outcome is achieved. Well, that is. And now, there is a book with a good example why BDD and specification by example could be a good idea. Imagine a project, car insurance premium calculator. You go to an insurance company, fill in the form like car, age, experience, accident happens, and software gives you an insurance amount. The guy who was working on this software received 400 pages with requirements, and he was free to start development process. But client says that he also has a spreadsheet with examples. It appeared that spreadsheet elaborate with several hundreds of examples on calculating an insurance cost. And the client expected that developer will use documentation during development process, and while the software is ready, he'll go through this spreadsheet and try examples to check if the system works fine or not. But it turned out that the documentation is not the main source of information. Instead of that, developer decided to use a spreadsheet by itself. He created a stub interface inside the system, and he connected Excel file to this system using VBA. He also created a query from spreadsheet to system. The spreadsheet was working in the following way. It contains data, rules, scenarios, expected results, and it sends a query with inbound data to the system. Then system responds, and Excel compares received amount with expected result. If values match, then it feels green. If values mismatch, then red. So as there was no risk calculation function in the system, the whole spreadsheet was red. Then developers started to look into requirements and develop features one by one. And when he produced the first version of application, some of fields inside this file turned green. So, in other words, some of scenarios started to pass. What is good in this file? That the spreadsheet was produced not by developer, but by the client. And client understands which scenarios are passing and what is the progress of development process. By the time, after few versions, the whole spreadsheet turned green. Yeah, and what is good in this approach, that in each point of time you have an automated testing library. Well, an automated testing library, and it's not just a library, it's also a working live documentation to your system. And if you have new requirements, then, for example, the client can amend this file with new scenarios, with new rules, and your documentation is consistent again. Well, um, what is also interesting in this approach that, well, you have a set of examples and you have software, and your software takes these examples and start to behave accordingly to them. What does it look like? Anyone? Okay, it's called machine learning, and BDD is close to machine learning in some way. The one problem is amount of examples. You need thousands photos of kittens in order to teach your system, a piece of software, to recognize a cat in a picture. And once again, the human beings learn exactly in the same manner, in the same fashion. You can observe some examples from your surrounding, from the environment, and start to behave accordingly to your experience. Well, I was talking about pros of BDD, and oh, thank you, finally. And now my colleague Alexander will proceed with its outer limits.
Okay, sound checking. Thank you. A magic one, thank you. Okay, there are several limitations of BDD I would like to talk to you. First of them, any good thing might be misused, like cucumber. You can use it for a healthy diet or for torturing people. In many projects like banks, exchanges and clearinghouses, when they try to apply BDD, they misused such instruments like cucumber and gherkin to torture the software testing engineers. Well, the very idea of BDD that QA, business analysts and developers look at the same user stories in the same acceptance criteria, writing in the same format, which is clear for everyone. And they will work together to improve these user stories and interact with each other about what is expected from the software, what can be or cannot be implemented. The easy way to see that BDD is not implemented properly is when the only party responsible for creating and maintaining gherkin scenarios is a software testing team. So it means that you don't use BDD. You use a gherkin language to describe your test. You use Cucumber to automate your scenarios, but you are not using BDD. It's unclear for many business owners, but it is the case. BDD is a collaborative process. When instead of collaboration you have only one party suffering, you using it badly. The next limitation, another way to fake BDD, is to create user stories which are not stories. Instead of creating user stories that are understood by everyone, you are not focusing on the meaning but only on the form. Instead of thinking about user story, you are faking it. It is also called a cargo cult. Please raise your hands who know what cargo cult is. Okay, very briefly. Cargo cult is a kind of religion that exists on several islands in Pacific Ocean. In the middle of 20th century, there were user war bases. Later, these bases were disbanded, and the local population started to create wooden headsets, build wooden radar towers, and they start to wave their hands, and they believe that these manipulations will summon great iron birds, which bring them a cargo with good things. That's the cargo cult. In software development, cargo cult is when you are following rituals without understanding the underlying logic and principles. For the same is with agile software development. You need to understand how it works. Instead, people start to use agile rituals like scrums, meetings, daily stand-ups. There are no more development cycles, only sprints. There are no more project managers, only scrum masters. But we can't afford to follow just rituals instead of doing the real things. How can a good user story be faked? Instead of implementing the sense of user story, it is possible to implement its form. It sounds like a joke, but in a very real project, implementing a new auction model for stock exchange, we observed the such type of user story. It was said, as a regulated exchange, I would like to do something to satisfy my regulatory obligations. A regulated exchange is not a user, and it does not want anything, but a human can. If you are impersonating such thing as regulated exchange or some other unusual entities, you just don't understand what a user story is. A user story is something that is useful for particular user. For exchange, users are members, brokers who submit orders, and they can understand what they need from their exchange and check whether it works. Also, market control, internal teams inside of exchange who can start, stop, operate, and monitor it works. These are also users, but an exchange is not a user. The next limitation of BDD. We work with very complex systems like trading and clearing. They consist of dozens distributed components, diverse reference and transactional data. What we have encountered in our projects, that often the legacy platform is already in place, and it interacts with 40 different systems. But no one really appreciates how it works. Everyone has a mental model how the system behaves. But frequently, if you are developing without BDD and you have no executable specification that you can check against every part of your software, often the requirements of the software will end up different from the actual implementation. You have created requirements from the beginning of the project, but then when you are implementing changes to the code, you forget to add these changes in the document. Years passed, and now there is a big gap between the software and the specification. It is a frequent situation in big projects. So having 3 amigos is not enough. Business analysts, developers, and QAs are not able to predict all the permutations. In order to do it, you need the 4th amigo, production logs. Production logs show how the system actually works against how people think it works. We do it in many different projects with exchanges and greenhouses where business analysts were thinking that the system works one way, but in production, the real connectivities to the real banks worked differently for many years. And when you start replacing the legacy system with a new one, you often breaks the things down. The 4th amigo is very important to complex systems already in production. Next problem that we find. When we apply BDD to testing trading systems, we experience challenges with all the parts of the process. The first part, given, a set of preconditions. It's like, in reality, in trading systems, there's multitude of a complex of settings and static data to configure their trading systems. It is like sitting in a cockpit with all these buttons and tumblers around you. Trading systems can have hundreds and thousands of tumblers and configurations that affect its behavior. So a set of preconditions is not a line, but a huge volumes of data. Sometimes people forget about the most basic configuration settings that affects their system's behavior. What will occur? In trading systems, we operate with multiple distributed layers of software components, and we deal with asynchronous communications between them. Often the same events can lead to different outcomes. In complex systems, there are frequently undetermined results. So it is required many details. It required a model to predict what exactly will happen until different circumstances. One more limitation of BDD. As we said before, QA, business analysts, and developers interact with each other during the BDD processes. In this situation, developers will know all your testing scenarios. Some QA believes that disclosing all their test scenarios to the developers would be cheating. But another QA thinks that this is silly. This position is silly. So, what can be a valid reason for hiding some of the test scenarios from the developers? Imagine two different situations. First, you need to create a robot that will go via remote control. You will control all this robot's actions. It is simple, but if you need to create a robot that goes to the building, and then this robot will have to do some manipulations inside this building without any control, that will be enough just a limited set of scenarios. It requires more effort. When you operate the stock exchanges market, you should be prepared for the unexpected, rather the having of limited sets of scenarios. So that's why sometimes it may be useful not to know the test scenarios that QA are going to use. It stimulates the brain and sort the process to create a more reliable system. So, the last limitation of BDD, let's talk about how to build a minimum viable project. There is a good meme in the internet, how to create your startup. This meme shows that you should not do it this way, but you should do it that way. On the picture above, you have one wheel, then next stage you have two wheels, then you have body car, and finally you have a car. Tell me please, why it is not right way for building minimum viable system? Who can say? Okay. Sorry? Yes, it's absolutely true. In the picture above, you don't have a working function in a piece of software until the very last moment in the software development cycle. You are not able to write the thing. The second one you can use on every stage. It is not a car yet, but at any point in time, you still have a product. This is the very essence of agile software development. You can use and provide immediate feedback to improve the product gradually until you have the end system. But what about testing of these products? In the first way, we can, in the both cases, we can use the final specification to test the product. So when we have only one wheel, we have a couple of green strings in our test that passed. Now, two wheels and more green strings. Then we have a body car and another green strings. And finally, when we test the final product, we have all strings green. So we have different scenarios that pass. But now, if we go in the true agile development process, if we prepare all the scenarios in advance, we will have all them failed. Because we don't have anything that represents the final product. If we just use the final specification to test agile, at every point in time, we will have all our tests broken. Because we don't have even a single wheel that matched the end product. This is the limitation of BDD. To summarize, let's once again, misusing things, focus on the format, focus on the rituals rather than on meaning, not focusing on the real things, not using production logs, and so on. Fortunately, in Exactpro, we find the ways to avoid these limitations thanks to production logs and model-based testing. So,